So today I want to talk about type 2 ionic compounds with special ions. Now how do you know whether they're special or not? Because during the test you'll be given a cheat sheet like this, and there will actually be a table that lists the special ions. Special ions come from things like the transition metals. Well, Mr. A doesn't like to talk about the transition metals a lot, but today we are. We're going to be talking about copper and zinc and some of those. They're just a little bit funny. That's why I don't like to talk about them with freshmen, because they're not as consistent as some of the other elements. They're not as consistent. What do I mean by that? They have more than one oxidation number. If you'll look at the list of special ions there, you'll see that copper shows up twice. You'll see that iron shows up twice, chromium shows up twice, lead shows up twice. So they have different oxidation numbers. I've written that list of special ions up here on the board. You'll notice that there is a parenthesis with a Roman numeral next to, these are the cations. These are all cations. Why? Because they all have a positive charge, right? These are all cations because they have a positive charge. Do you notice the relationship between the charge on the ion and the Roman numeral? Yes, you do, right? So if it is a positive 1 charge, then it's got a Roman numeral 1. If it's a 2 plus charge, it's a Roman numeral 2. If it's a 3 plus charge, it's got a Roman numeral 3. If it's a 4 plus charge, it's got a Roman numeral 4. In case you didn't learn this in middle school or elementary school, these are the Roman numerals. You may have seen them when they advertise the Super Bowl. They always advertise the Super Bowl with a set of Roman numerals. I forget what we're up to now. But we're really, for what we're talking about today, we're only going to go up to Roman numeral 4. And that's just a fancy way to write it. You will always see the parentheses, and that goes with the cation. It conveys the information as to which oxidation number it has. So copper has an oxidation number of 1. It also has an oxidation number of 2. So how do you know which one? They will either tell you, or you have to figure it out. Okay, so let's get into this, and let's do, what are we doing first? You got a question?
Yeah, I got a question.
Yeah.
Is there negative versions of that?
Okay, so if it had a negative charge, it would be an anion. And all these special ions, they're all cations, so they're all positive. Roman numerals for anions. Yes. No, you're absolutely correct. Okay, so again, we are on page 2 of this packet where it says binary ionic compounds, and the first thing we're going to do is names to formulas. Okay? So names to formulas. You remember our strategy for coming up with a formula from a name is to do an upside down T-chart. Okay? So here's my upside down T-chart. We're going names to formulas, so here's the name, and we want to end up with a formula. Okay? So, let's try our strategy. What do I do? I'm going names to formulas. Do you remember from last class?
Yes.
Help him out. Somebody help him out. What do I do? Upside down T-chart.
Where's copper on this?
Where's copper? It's one of the transition metals.
Is it Cu?
It is Cu, right? So your inclination would be to write, the first thing that you do is you write the symbol on this side for the cation. This is a cation. It's not cation, it's cation. And here's the anion. All right? So you write copper, and then what is nitride? N. It is N, right? You recognize that, well, you know, nitride is not on the periodic table. Nitrogen is on the periodic table. Nitride is the name that we give nitrogen when it's in a compound. We all know that now, right? All right, now we have to write the oxidation number, all right? And I want you to do this. The key to this, start with the anion, okay? Start with nitrogen. What's the oxidation number for nitrogen? -3. Okay, so be careful. We all know how to look up oxidation numbers. In fact, the oxidation numbers are written on top of the elements in the periodic table on the backside, on the scrunched up one. So we have an N of a 3 minus, okay? what's the oxidation number of copper?
1 plus and 2 plus.
We don't know, do we? There's 2 of them. We don't know. What are we going to do? You going to pick one? No. You have to be told. Okay? When you're going names to formulas, you haven't named it, or whoever's telling you hasn't named it unless they include the parentheses and the Roman numeral. I asked you just a minute ago, did you get the connection between the oxidation number and the number in Roman numerals? So if there's a Roman numeral 2, then what must this oxidation number be? It's a 2 plus. Okay, now we know what to do. If we have the symbols and the oxidation numbers, then we play this balancing game, right? If we were to bring these oxidation numbers down now, we would get a 2 plus and a 3 minus. Of course, they don't equal 0. So we're going to need more of the one that's less, right? So I'm going to write another copper 2 plus. That makes this a 4 plus and a 3 minus. That doesn't equal 0 either. So we're going to add one more of the one that has less. So we're going to add another nitrogen. And so that's going to make a -6. Oh my gosh, how long is this going to go on? This isn't equal to 0, so I'm going to have to add one more to the side that's less, and 2 plus, and this makes this a 6 plus, and Santa Claus has come to town. Now they both equal, one's a +6, one's a -6, and they equal 0 now, right? So now we're done playing the game with our strategy, and we can just write the formula by counting the number of particles and using the correct subscript, right? So, Elijah, how many times did I write in up here?
2 times.
I did, so I write in with the subscript of 2. David Hastings, how many times did I write copper up here? 3 times. So I write copper with a subscript of 3 and drop the mic. We're done. The formula for copper to nitrate is copper or Cu3N2. Okay? Now, what I want you to do is there's some practice there for you to do. See if you can do this, names to formulas for type 2 ionic compounds with these special ions.